So next one, I'm going to talk about damped free mass spring. So damping constants involved, but there will be no external force. So difference equation going to be this: my dou prime plus by prime plus ky equals 0. So since the b is not equal to 0, so when you find that Ox equation, we got mr square plus br plus k equals 0. So now r is going to be what? Negative b plus minus square root and the b squared minus 4mk over 2m, right? Okay. So that's why. So we got this one. That's why we can we need to think about three cases. B squared minus 4mk, which is discriminant, is less than 0, 0, greater than 0, right? So case 1. So b squared minus 4mk, b squared is less than 4mk. So this is called the underdamped. Okay. So underdamped mass spring system, which means that the spring force is under control by the damping force. So what does that mean? So damping force is greater than spring force. So we're not gonna, in this case, it will not happen the oscillation. So R is gonna be here, then R is alpha plus I beta, plus minus I beta, you can say that, right? This complex conjugate root, right? So alpha is minus b over 2m, and a beta, you know, this is complex conjugate. Conjugate root. Okay, so alpha is minus b over 2m, right? And the beta is 1 over 2m times square root b squared minus 4mk. So general solution, we know, right? We did how to find we did how to find our general solution when the Ox equation has two complex root. So yt is c1 times e to the alpha t, right? And a cosine beta t. Plus c2 times e to the alpha t and the sine beta t. Right? So this is equal to, that is equal to e to the alpha t, right? And then c1 times cosine beta t plus c2 times sine beta t. Okay. Now what? See that c1 times cosine beta t plus c2 times sine beta t. We learned that how to combine these two terms as one single trigonometric function. So this is e to the alpha t, and then what? A times, isn't it? A times sine, right? And then beta t plus phase angle pi. So let me just write down A first. A is equal A times e to the alpha t, and then sine in a beta t plus pi. This is beta plus t plus pi. Okay. So now the big difference between the damped. Give me a second right here. This is undamped, right? So this is undamped. Example 1, right there. Give me a second. Oh, right here. The general solution. In this case, in 4.9, right there, the undamped and the free mechanical vibrations. The solution was this: A times sine omega t plus pi, right? There is no exponential term. But now, in damped free vibrations, mechanical vibration system, we got we got the exponential term right there, right here. So the exponential term right here, and then what is alpha? Alpha is minus b over 2m. It's a negative, right? All the constants of property is positive, b is positive, and m is positive, but so alpha is negative. So this one is a decreasing function. So we see that, oh, okay, it's gonna have the what, the under we have the vibration, but the amplitude will decrease, right? So because of this is decreasing. Okay. So now you say here A, now y of t. You can say y of t. Let me use other color. So y of t is equal to a times e to d alpha. What is alpha? Minus b over 2, right? T, and then sine in a beta t plus pi, and a is going to be square root of c1 squared plus c2 squared. And then yeah, pi, definitely pi is the arctangent, right? Arctangent of, let me just tangent. Tangent pi is c1 over c2. Okay. And beta is beta is going to be what? This one right here. So let me. I'm not going to repeat writing this. So you know, the a times e to the exponential of this is called the exponential damping factor. This is sine factor. Okay. So now here period gonna be 2 pi, right, over beta. Okay, and y of t. So then what's the period? Sine factor. Without considering exponential damping factor, the period of sine factor is 2 pi over beta, right? So let me put this one. So yeah, sine factor. Okay, but we need to consider exponential damping factor too. Those things. But so what? Without with the exponential damping factor, actually there will be no period, because the graph of the this one will be like this, because the amplitude will be decreased by the exponential term, right? So the wave is not the keep going with the same amplitude. Its amplitude will decrease. So we cannot apply the concept of period of frequency same as the previous problem here. So but we see that we can say period is here, from here to here, and here to here, here to here, but I know the amplitude is different. So this is called the quasi period. Okay, so so y of t the quasi period of p, this is a 2 pi over beta. Okay, period of sine factor is this, but the quasi period is the period of this y of t. Okay, and quasi frequency is 1 over p. Okay, so 1 over p. So I told you graph. Let me draw the graph. Here's a t, and this is a y. So graph is this. Okay. So that's the graph of exponential damping factor, a times e to the alpha t. Okay, that's going to be what, minus a times e to the alpha t. Okay, and from here to let's say right here, let me say here, okay, here to here, that's a quasi period. Which is a 2 pi over beta. And yeah, that's the graph of a times e to the alpha t plus sine beta t plus pi. Okay. So now next one is the overdamped. Okay. So overdamped is the b squared is greater than 4mk. Oh, give me a second. Yeah. Case 2. So b squared is greater than 4mk. So this is called overdamped. Okay. Hold on a second. The case 2 is b squared is greater than 4mk. So it's overdamped. So Ox equation, we got two real root. Okay, r1 is minus b over 2m and a plus 1 over 2m. Okay, and let's just say r. Okay, r is a plus minus. Okay? R is equal to plus minus b over 2m plus minus 1 over 2m times square root of b squared minus 4mk. So general solution is going to be c1 times e to the r1t plus c2 times e to the r2t. So as you can see that there is no trigonometric functions involved in y of t. It's just exponential functions, right? So depending on sign of r1 and r2, so the behavior of y of t will be different. So excuse me. Okay, so let's figure out the sign of R1 and R2, which means that we need to figure out the inequality between two terms. This one and this one, right? So depending if b over 2m is greater than 1 over 2m times this guy, right? Or then what happened? Then what? I mean, this guy is greater than this one, right? You see? Then R1 gonna be R1. So R1, R2 right here. This is a minus b over 2m, and then plus 1 over 2m, the square root, and then b squared minus 4mk here. Okay, if this guy is greater than this, what happened? Then R1 must be positive. R2 is always negative, right? Minus 1 over 2m, the square root, b squared minus 4mk. Okay, for whether or not this one is greater than this guy, or this one is greater than this guy, R2 is always negative because this is, look at the sign. But the problem is R1. If I told you this second term is greater than its first term, then R1 turns out to be positive. Okay, so we need to figure out that. So first one, b squared. Since the b squared is greater than 4mk, then b squared minus 4mk is what? Is greater than 0, and what? B squared is greater than b squared minus 4mk. Is that makes sense, right? Because b squared is greater than b squared minus something, right? So implies since this one b square, b is greater than what? Square root of b squared minus 4mk. Because when you just take a square root, take a square root on both sides, then what? B is greater than this. And keep in mind this: m and b and k, all three, the constant property is positive. Okay, keep in mind this. So since the so b is greater than this guy right here, that means what? R is negative. Thus, R1 is less than 0. Okay? You got it, right? Because these two guys, the fractions have the same denominators. So we just compare the numerators, b and square root b squared minus 4mk. It turns out that b is greater than this guy. That's why R1 is less than 0. Okay, and then obviously R2 is less than 0, which means that both terms are decreasing function. Right? So y of t is decreasing function. Decreasing function, right? Okay. And then is there, okay, decreasing, there are two types decreasing, right? Like this. There is a local maximum, minimum, right? Even though y of t decreasing, probably there will be a local maximum, minimum. But so to figure out that, we need to figure out the y prime. So y prime is what? E to the r1t times c1 r1 plus c2 and then r2 and the e to the r1 minus r2 and t. Okay, this is simple, calculus. Just simple calculus. So as you can see that this is always positive, right? And then R1, R2 are not 0. Okay, so this is always positive. So there is no, there will be only what? One maximum or local extrema. Okay, because this is positive. Think about this. This guy has at most one one root, depending on initial conditions C1 and C2, right? So why we find out y prime? Because we want to find the critical point. Do you remember that when you find the local maximum minimum in calculus 1? So to find the local maximum minimum, we got to find the critical point. So critical point is what? Solution to root of this equation, right? So in what case, how many solutions we can expect in this equation? Y prime is 0. I think R1 0, or I don't think R1 R2 gonna be 0. So depending on C1 and C2, right? Then can you say that C1 and C2 have multiple numbers? No, C1 C2 will be determined uniquely by the initial conditions. So there will be only one root for this equation. So this guy has y of t has at most local extrema means a maximum or minimum. Both are called the extrema. Okay. One local extrema. Okay. So so in this case we got 3 cases. These are graph of for each case. Each case, no local extrema, one local maximum, local minimum. The last case, which is that b squared is equal to 4mk. So this is called the critical density system. So since discriminant is 0, so r must be minus b over 2m. The second term just gone. So plus minus term, and the y of t is equal to c1 e to the r t plus what? c2 times t times e to the rt. Okay. So and then what? R is less than 0 because b and m are positive. So thus y of t approaches 0 as t approaches what? Infinity. Yeah. So And similarly, we need to check that what we need to figure out if y of t has local extrema. So we find that y prime t, okay, so e to the rt times c1r plus c2 plus c2 and then tr. So in this case, y of t, y prime t equals 0 has only one solution, which means that at most. So y of t has at most one critical point. Yeah, so thus y of t has at most one local extrema. Okay, I told you. So yeah, y of t, the motion of y of t is unoscillatory. Okay, so this is the graph of y of t is similar to the case 2. Okay, so please see the example in textbook. Okay, then you can fully understand the three cases. So I told you, please read the example in the textbook. So we move to the 4.10. Okay.